Let's think step by step of 4 words. Same model, same question, and reasoning accuracy roughly doubles. No new training, no bigger chip. Just that phrase typed before the answer. Here's why that's strange. It's free, no fine-tuning, no extra hardware, and it works on the models you already use today. But here's the puzzle. The model already knew the answer. So how does telling it to slow down change what comes out? That gap is the whole story. So what is chain of thought? It's simple. Instead of blurting the final answer, you get the model to write out the middle steps first. Watch the difference. Ask a model a 2-step word problem. A store has 23 apples, sells 17, gets 12 more. If it answers directly, it often just says the answer is 7, confident. Wrong. Now force it to show work. First, 23 minus 17 is 6. Then 6 plus 12 is 18. So the answer is 18, same model. Same question. This time it lands.
Why does writing first then so rescue a problem the model fumbled a second ago?
Because the answer isn't one leap. It's a chain, and jumping straight to the end skips the links. Direct answering asks for the destination with no road. Showing work builds the road one segment at a time. The model can only stay on track if it lays that road down in front of itself. That raises a sharper question. Where does the extra thinking actually come from? Here's where it gets mechanical. A transformer, the engine inside these models, does a fixed amount of computing for every word it produces. Think of each word as one pass of thinking and only one. So if the model answers in a single token, it gets exactly one pass to solve the whole thing. One shot. That's the trap. When you make it right reasoning first, every word of that reasoning buys another pass. Literally more computing spread across more steps. 20 words of scratch work is 20 passes instead of one. And there's a second effect stacked on top. Each step the model writes becomes part of what it reads for the next step. It's conditioning on its own scratch work. Building on the line it just wrote, the way you carry a number down a page of long division. The steps aren't decoration. They're working memory the model didn't have when it tried to answer cold. More passes plus a growing scratch bed it keeps rereading. That's the real machinery.
But if it's just spending more compute, why does one specific phrase flip the switch?
Why step by step and not any other words? Now the why this phrase question. The model didn't invent step-by-step reasoning. It read it millions of times. Its training data is full of worked math solutions, homework tutorials, and textbooks where someone explains a problem line by line. So the phrase think step by step isn't a magic spell. It's a trigger.
It nudges the model into the statistical groove of every work solution it ever saw, where answers arrive slowly and show their reasoning.
You're not adding a skill. You're picking the patterns. And there are 2 ways to flip it. 1, add the phrase cold. No examples, just let's think step by step. That's called zero shot. You prime the behavior with words alone. 2, show it 1 or 2 solved examples first, then ask your question. That's few shot teaching by demonstration. Different door, same room. Both drop the model into the same careful show your work mode. So the 4 words work because a mountain of human explanation already lives inside the model, waiting for the right cue. Which brings us to the part everyone actually wants to see. How big is the payoff and where does it show up? Now the numbers. On grade school math word problems, the standard benchmark for this, accuracy on some models jumps from around 18% to over 40% just from adding the phrase. Same model. That's the roughly 2 times gain, and on certain tests the gain lands near plus 58% on math. Say that again. A plus 58% swing from 4 words. But the gain isn't uniform, and that's the tell. The biggest jumps show up on multi-step math, logic, and symbolic puzzles. Anything that needs a chain. On simple recall or one-step lookups, it barely moves the needle, because there's nothing to chain. Here's the sharpest clue of all. The bigger the model, the more dramatic the jump. Small models barely benefit. You can beg them to think step by step and they still stumble. That pattern only makes sense one way. The steps aren't teaching the model new facts. They're releasing an ability it already had but couldn't reach in a single pass. The capability was sitting there latent, locked behind the one-shot answer. So the phrase doesn't make a model smarter. It lets a capable model finally use what it's got.
But is the reasoning it shows you actually true?
Now the catch, because there's a big one. The reasoning the model writes out is not always the real reason for its answer. Sometimes the model lands on a conclusion, then writes a tidy explanation that sounds airtight but had nothing to do with how it actually got there. It's an after-the-fact story. So a confident, beautifully argued chain can still be flat wrong. Don't be hypnotized by neat steps. There's a cost too. Every reasoning word is a token you pay for. More money and more weightings. On a question that needs a fast, direct reply, all that thinking is pure overhead. And on some simple tasks it actually hurts. The model talks itself out of the right answer. So when should you skip it? Simple factual questions. sorting things into buckets, and any case where a wrong but confident explanation is worse than a plain, humble answer. Because a fluent wrong chain fools people harder than a blunt one. Step by step is a tool, not a setting you leave on forever. Which leaves one honest question. If the reasoning can lie, what are those 4 words really buying you? So here's the whole thing in one frame. The 4 words don't make the model smarter. They do 2 concrete things. They buy it more computing, 1 pass per word instead of 1 pass total. And they drop it into the step-by-step patterns it already absorbed from millions of work solutions. More compute plus a groove it already knew. That's the entire trick. So use it on purpose. Reach for let's think step by step on math, logic, and anything with real intermediate steps. That's where the 18 to 40% jump lives. Skip it on quick facts and simple sorting. And the one rule that matters most. Check the final answer, not the pretty reasoning. Verify the destination. The chain can be a lovely story wrapped around a wrong number. So trust the result you can test, never the confidence of the steps. 4 words, more compute, measurably better reasoning. That's chain of thought. And here's the natural next question. What happens when a model does this automatically, without you typing the phrase at all? That's exactly what the new reasoning models bake in. And how they do it is a machine worth opening next.